All right, number 10, we have a piston is seated at the top of cylindrical chamber with the radius 3 centimeters. When it starts moving into the chamber at a constant speed of 5 centimeters per second, what is the rate of change of the volume when the piston is 13 centimeters from the base? So we have a visual here, and we want to know the volume is changing. So we need volume of a cylinder that is a circle, which is pi r squared times the height. We have that this piston starts moving in, so the height is changing. It's decreasing, so if the height is here, then the height is going down, the volume is going down. So we're going to say dH dt, so that's the rate that the height is changing. dH dt is equal to 5 centimeters per second. I'm going to make that a negative. And we are looking for the rate at which the volume is changing, dV dt. And that should come out negative. Alright, so we're going to just take the derivative of this function. Now r is a constant. The radius, where we're given the radius is 3. So that we can plug that in. Radius is not changing, it's going to stay fixed. So volume is, it's going to be 9 pi h. That's 3 squared is 9. 9 times pi times h, and we're going to take the derivative of this function. dV dt. This is a constant, it's going to be 9 pi, and then the derivative of h is going to be dH dt. And all we have to do is plug in the height. We want to know what rate the volume is changing when the height is 13 from the base, which we don't even really get to use that. We just need the dH dt part. So we have 9 times pi times negative 5. Let's see, second. Now the 9 squared, that's centimeters squared. Gotta keep those units. 9 times 5 will give me a negative 45 pi. We want to round to the nearest hundredth. Alright, so we just compute this with the calculator. Do 45 times pi. It should be negative. Here's 100, negative 141.37. Centimeters cubed per second.